Hello everyone, welcome to topic 7.3, reaction quotient and equilibrium constant. By the end of this, you should be able to represent the reaction quotient, QC or QP, for a reversible reaction and the corresponding equilibrium expressions, KC equals QC or KP equals QP. So by the end of this, we should be able to write those. And they give some examples in the expanded part and brings up the equations we're going to learn. So, some reactions reach equilibrium when there's more product, while other reactions reach equilibrium with fewer products. The reaction quotient, Q, describes the relative concentrations of reaction species at any time. At equilibrium, the reaction quotient is equal to the equilibrium constant K. So Q is relative concentrations at any time, whereas K is only at equilibrium. So Q helps us see where the reaction is with respect to its equilibrium placement, which is actually a topic we'll get into later this unit. We can write the reaction quotient or equilibrium constants in terms of concentration or partial pressures. However, solids and liquids are not included in the reaction quotient or equilibrium constant expression because they are pure substances and their concentrations do not change with volume. When writing a reaction quotient or an equilibrium constant expression for a system with solutions, use the concentrations and label it as Q or K with a subscript of C. When writing reaction quotient or equilibrium constant expressions for a system with gases, use partial pressures and label those two with a subscript of P. And they are a little different, as are the units. So the KC and KP, or QC and QP, are not going to be equal, okay, because you're using very different units. Okay, so when we write the expressions for solutions, we have this one. For gases, we have this one. I do want to add that you want to pay attention to what units you're given. If you're given units for pressure, make sure you are writing your expression in terms of pressure. If you are given pressures and you write it as though it's concentrations here, as this one, you will not receive those points, okay? You have to pay attention to what units you're given. If it's molarity, use concentration, so square bracket. If it's pressures, you're going to use P with the substance denoted as a subscript. Okay, something else to note is that the coefficients are the exponents. Okay, so it's always product over the reactants to the power of their coefficients. Okay. So continuing on, we have a couple examples here where we see expressions written for a solution reaction, an expression written for gases. Please remember that solids and liquids are not included and that the reaction is balanced. There is a way to go between the two, KP and KC, but it's not tested, so I'm not going to spend a lot of time on that. So let's look at how we can apply this. Okay, so if we look at this, write the equilibrium constant expression for the following system at equilibrium. And so we're given this. Well, when we look at this, we see that we have gases all the way across. So that tells us that we're going to use KP rather than KC because we're more likely to get units in terms of pressure units for gases. Okay, because that's how gases are measured. So it's always products. So I'm going to need the pressure CO2, and I raise it to the exponent of its coefficient, which is 3. times the pressure of H2O to its exponent. So it's always products over reactants. So then I take my reactants and then C3H8, and its coefficient is 1, so I don't have to write it. And then the pressure of oxygen gas to the 5th power, because that is its coefficient. So this is the equilibrium constant expression for the following system at equilibrium. Now looking at the WEDO, solid calcium carbonate, CaCO3, produces solid calcium oxide and carbon dioxide gas. Write the balanced equation and then write the reaction quotient. The reaction quotient is Q. Okay, so please pause the video and take a minute to do that. Okay, so writing the reaction, you should start with your reactants, and it says it produces solid calcium oxide and carbon dioxide gas. If you check the stoichiometry, you see that it is balanced. Then writing the reaction quotient, you know you do not include solids in that expression. So the only thing that'll be in that expression is carbon dioxide gas. Since it is a gas, we're going to use QP. And so QP is equal to the pressure of carbon dioxide, because there is no coefficient, so I don't have to raise it to any power. So that concludes this section of notes. Using these notes, please complete the you-dos that follow, check your work, and thank you for tuning in.